Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I'll be taking the preparation of alcohols from the alcohols, phenols and ethers chapter. Last time we have seen regarding the nomenclature of alcohol, so we will continue that part with the preparation of alcohols today. Okay, so let us start the preparation of alcohols. Now there are different methods to prepare alcohol. Okay, so we will see one by one. First is from alkenes. Okay, so how to prepare alcohols from alkenes. The first method is by acid catalyzed hydration. So what we do here, we add some acid, that is H2SO4 or HNO3, okay, and water along with that. So what happens here, when you add acid plus water, the double bond will break here in the alkene, and to both the carbons the one positive and negative groups will be added. So we will get here water, we have H and OH minus ion. So H will go and attach to carbon and OH will go and attach to the other carbon. So what we will get here, to one carbon H and other carbon OH will be attached. Now this is in case of symmetrical alkenes, wherein you don't have to see a particular carbon to which you are attaching the groups. But what happens when we use unsymmetrical alkenes? So when we use unsymmetrical alkenes, we have to look for the carbon which is having less number of hydrogen and carbon which is having more number of hydrogen. So here I have taken one example in which I have one carbon having less hydrogen and carbon having more hydrogen. So here when we add water, what will happen? We have one H plus ion and OH minus ion. So here we have to follow Markovnikov's rule. Okay, whenever we have unsymmetrical alkene, we have to follow Markovnikov's rule. So according to Markovnikov's rule, we will have CH3 CH. Now the negative part will attach to carbon having less hydrogen. To this CH, OH will attach, and then we will have CH2, right? So CH2, H will attach. So we will have CH3 in place of CH2. Okay. So this is the product that we will get when we react unsymmetrical alkene, that is propene, with water. Then what will be the name of this compound? This compound will be called as propane 2-ol. Okay, so this, the name of this compound is propane 2-ol. Now next is hydroboration oxidation. Okay, in hydroboration oxidation, what we are doing, we are taking an unsymmetrical alkene with a diborane compound. Okay, so diborane is now split into two, that is positive ion and negative ion. Okay, so when we add this diborane to alkene, what happens? Here this will follow anti-Markovnikov rule. Now when a compound follow anti-Markovnikov rule, whenever there is an presence of peroxide. Okay, so here we are using peroxide to so the effect will be anti-Markovnikov. So what will happen? The negative part of the compound will go and attach to carbon having more number of hydrogen, and positive part will go and attach to carbon having less hydrogen. So here you can see, to this carbon with here and to this carbon the H is attached, and this carbon, the negative part BH2 is attached. Okay, so now we want trialkyl borane compound which will be then converted into alcohol. So that's why we have to oxidize this compound in such a way that it will be converted to trialkyl borane, and then it will be oxidized to an alcohol. So after adding alkene, okay, further you have to add alkene 2 times, so that here first I got H attached to CH and then BH2 attached to CH2. Again I have added alkene, so that the alkyl group is twice and one more H is reduced from here, B. Okay, so this was BH2, now it is BH. Again if I add alkene, what I will get? I will get CH3, CH2, CH2, CH3, that is thrice. Okay, and to that boron is attached, that is trialkyl borane. Now I got a compound with borane, so that I can add the peroxide. So after adding peroxide, what will happen? I will get the product, that is alcohol. Okay, and I will get the addition product here. Okay, so now after adding peroxide, I will see the effect over here. That is, I will get a propanol which is formed by anti-Markovnikov's rule. Okay, so this was the product by hydroboration oxidation reaction. So only thing you have to remember here that we use anti-Markovnikov's rule in hydroboration oxidation reaction. Okay. The next is from carbonyl compounds. Carbonyl compounds. Which are the carbonyl compounds? Aldehydes, ketones, carboxylic acids. Okay, wherein you are having C double bond O group. So first we will see reduction by reduction of aldehydes and ketone. So first we will see the reduction of aldehyde. When we take aldehyde and we carry out the catalytic hydrogenation, we get primary alcohol. Okay. Now the hydrogenation means what? Addition of hydrogen in presence of any catalyst. You can take palladium, nickel. Okay. So here palladium is taken. Now I will show one example here. If I take CH3CHO plus H2 in place of presence of palladium, what I will get? We'll get CH3CH2OH. So what happened here? RCHO is getting converted to RCH2OH. So here there is CH, okay, and here there is CH2. That means there is one more hydrogen added here, and also here one more hydrogen is added. So I will get CH3CH2CHO, that is aldehyde on hydrogenation in presence of catalyst will be converted to same alcohol. Okay, so if this is, what is the name of this? This is ethanol. So ethanol in presence of hydrogen and catalyst will give us ethanol. Okay, so ethanol to ethanol conversion using the catalyst and hydrogenation. Okay, now the alcohol which we get here is always primary alcohol. Okay, when we will get primary alcohol? When we use an aldehyde. If you use ketone, okay, if you use ketone, that is RCOR, what we are going to get in presence of this sodium borohydride? We will get ketone. Okay, we will get secondary alcohol. So I will write example here: CH3 C double bond O C2H5. Okay, I have taken different alkyl groups here in presence of sodium borohydride. I will get CH3 CH C2H5 and OH. Okay, so this is the alcohol, corresponding alcohol I will get. What is the name of this ketone? First we have to check for carbon. 1, 2, 3, 4. There are 4 carbon. Okay, so the name will be, now you have to start numbering. I will start numbering from this carbon. So 1, 2, 3 and 4. Okay, so the name will be butane 2-one, and this name will be butane 2-all. Okay, the name of this will be butane 2-all. So the same number of carbon chain is going to give us this same number of alcohol. Okay, alcohol group. Then the second method here is by reduction of carboxylic acids and ester. So carboxylic acid, that is RCOOH. Now this is a reducing agent, lithium aluminium hydride in presence of water. It is going to give us the alcohol. Okay, so let us take example here: CH3COOH, which is acetic acid, or we can say ethanoic acid, in presence of LiAlH4 and H2O will give us CH3CH2OH, which is ethanol. Okay, then now this lithium aluminium hydride is an expensive reagent. So while carrying out the reactions commercially, people don't use this reagent. So that's why one replacement is done here. First, the carboxylic acid is converted to an ester, and then ester is converted to alcohol. Now this is not that expensive method, that's why this is used. So carboxylic acid, that is, I will take example here, CH3COOH along with one alcohol, let us take CH3OH. Okay, presence of proton, it will give us an ester, that is CH3 COOCH3. Okay, then this ester is then converted to an alcohol. So ester and some catalyst is used here to give CH3 CH2OH plus CH3OH. So another alcohol. Okay, so there will be two alcohols molecules which will be formed here. Okay, so this is the reaction by reduction of carboxylic acids, and second one is ester. Now what will be the name of this? This is acetic acid or ethanoic acid. Then the name of this ester. Ester name ends with oate. Okay, so the name will be here methyl methanoate. Methyl will be substituent and methanoate will be main chain. Same groups are there, so here no need of writing checking for which group is having more carbon atoms and less carbon atoms. Then in presence of catalyst it will give us alcohol. So the alcohol, this alcohol is ethanol and we will get methanol. So this is about the from carbonyl compounds. Now next is from Grignard reagent. Now most of you all must be knowing what is Grignard reagent. When we combine alkyl group with magnesium, metal and halide. Okay, so ketone, when it is reacted with Grignard reagent, it will give us one adduct. Adduct means what? The addition product. Okay, so here ketone, when you react with Grignard reagent. Now Grignard reagent is having alkyl group along with metal. Now since we know metal is more positive because metal is having tendency to lose electrons easily. So alkyl group already it is positive, but when another more positive metal is attached to the alkyl group, this will carry a partial negative charge. So along with the metal this will become negative. Okay, so that's why it will carry a negative charge. Okay, now this is having a negative charge. So what will happen here? There will be an attack on the negative charge. Okay, so there will be attack this way. Okay, this is negative, this is positive, so there will be attack. So R will go and attach to the carbon bond directly and this bond will break. So we will get this O and this MgX attached to the O. So we will get carbon with OMgX and R attached to the carbon. Then this is an adduct and this is not stable. Okay, so what you have to do, you have to add a water molecule to it to form the stable product. So we will get the same, this group will be same, and in place of MgX we will get an H attached here, that is OH group will be attached and this will be the formation of alcohol. Okay, so this is the mechanism what I have explained here, and the addition product will be this MgOH X. Okay, so we will see the first reaction here, that is HCHO. HCHO is methanol. When methanol is reacted with Grignard reagent, it will give us one adduct, that is RCH2O MgX. When it is further reacted with water, what we will get? We will get an alcohol with the addition product. Okay. Now what we have to remember, whenever we use methanol with Grignard reagent, we will get a primary alcohol. Okay. So that's why I have written this reaction separately. Okay. Then if I use aldehyde, a higher aldehyde than methanol, suppose if I take CH3CHO, that is ethanol plus C2H5MgCl. I will take Cl in place of halogen. Okay, so ethyl magnesium chloride I have taken. Then what I will get? I will get CH3CH C2H5OMgCl. I will get this product as an adduct. Okay, so after reacting this with water, I will get CH3CH C2H5OH plus MgOHCl. So the name of this product will be 1, 2, 3. Okay, 1, 2, 3, 4. Now here this will be the main product. This will be the main product and CH3 will act as a substituent. This will act as a substituent. This will be main chain because here we are having 2 carbon. So the name will be 2-methyl 2-methyl propanol, propan 1-ol. So the name will be 2-methyl propanol. Okay, and this will act as a substituent and OH group is attached to the first carbon. So numbering will start from here. So 1, 2, 3, 2-methyl propanol. Okay, now this is from ethanol, which is an aldehyde. Now what you have to remember, when you use aldehydes, okay, which are having carbon more than 1 carbon, you will get secondary alcohol. So OH group is attached to the carbon, which is further attached to 2 carbon. So you will get a secondary alcohol. Okay. But when we use ketone, that is R C double bond OR, so I will take directly an example, CH3 C double bond O CH3, and if I react it with CH3 MgBr suppose, okay, methyl magnesium bromide, then what I am going to get? Ketone. I have reacted now, so CH3C, all groups I have taken are CH3 groups only, so I will get OMgBr, okay, which is an adduct, which is further reacted with water. I will get CH3 C CH3 OH. So what I am going to get here? Tertiary alcohol. Okay, so here I will get tertiary alcohol. Okay, so what you have to remember, that whenever we are using Grignard reagent, okay, whenever we use Grignard reagent, when we use aldehyde, that is the first aldehyde methanol, that time we will get primary alcohol. But we use whenever we use higher aldehydes, okay, whenever we have more than 1 carbon, that time we will get primary alcohol always, and when we use ketone we will get tertiary alcohol. Okay, so this is the thing that you have to remember. Okay, now these are the main preparations of alcohols, that is first from alkenes, then hydroboration oxidation, from carbonyl compounds, and from Grignard reagent. Now let us take example here and we will see how to solve this. Now the first question here is catalytic reduction of butanol. Butanol means what? Aldehyde. So first let us write the structure, that is CH3, CH2, CH2 and CHO. So this is the structure of butanol, the formula of butanol. Catalytic reduction means what? Here what we are adding? Here we are adding H2 and any catalyst. So I will take palladium here. So what happens when we carry out the catalytic reduction? The corresponding aldehyde is converted to that corresponding alcohol. So here butanol is there, so I will form butanol. So you need to know the reagent which we are using and what is going to form. Okay, so here butanol is converted to butanol. So the structure, the formula will be CH3, CH2, CH2, H2OH. Okay, so reduction means what? Addition of hydrogen or removal of oxygen. So here addition of hydrogen is taking place. So we will get butanol to butanol in presence of hydrogen and palladium. Catalytic word should strike you with that palladium word or nickel word. Okay, catalyst which we are using, that you should know. Okay. Then next is hydration of propane in presence of dilute H2SO4. Hydration means what? The name itself tells us that hydration means we are adding a water. So hydration of which compound? Propene. So I will write CH3, CH2. Now this is the formula of propene in presence of dilute H2SO4. So first hydration means water is needed, and this is a reversible reaction. So in presence of dilute H2SO4 means I will directly write the acid here. Now why acid is needed? Because we are taking proton from here. Okay, so in previous reactions we have not written acid formula, we have just directly written the H plus. So here we will write, because they have given H2SO4, we will write H2SO4 here. And what happens when we add water and when we carry out the hydration? Okay, so water, we know that it will give H and OH minus ion. H is positive, OH is negative. And what we had studied about the reaction, acid catalyzed reaction, that it will follow Markovnikov's rule. So negative part will go and attach to carbon having less hydrogen, and positive part will attach to the carbon having more hydrogen, and double bond will break. So what product we will get? We will get CH3, CHOH and CH2, one hydrogen is added, so it will become CH3. The product name will be propane 2 all. Okay, so if you understand the reaction, okay, by its mechanism, meaning what is happening in that reaction, it will be easy for you to understand the reaction. There is no such method wherein the reactions can be made easy, or any tricks or any hints are applied over here. So the only tricks are, you need to remember the name of the reaction. Now there are so many name reactions, so you need to remember the name of the reaction, and along with that you have to remember the reagent what we are using. Okay, now the basic things here you need to understand is what is oxidation, what is reduction, and with that you need to understand what are reducing agent, what are oxidizing agent. So there are few oxidizing agent, which we are using in the reaction. So if you understand this, it will become easy for you to understand the reaction, how it takes place. Okay, then some rules you need to understand, that is Markovnikov, anti-Markovnikov. So it will make the reactions easy. Okay, now yeah, so with this we finish our this lecture. Okay, now in next part I will tell you all about the preparation of phenols. Okay, so for more such videos subscribe our channel, and you all can watch the videos over there. Thank you.